We're going to talk about reactions now. And before we get into chemical reactions, we need to talk about the differences between physical properties and chemical properties, as well as physical change and chemical change. Now, basically, a physical property is anything that you can measure without changing the substance. Mass, volume, color, texture, the phase of matter, those are all properties of matter, physical properties. Chemical properties of matter can only be observed when we're actually changing the property, changing the substance into a new substance. So I don't know that something is combustible, flammable, or explosive until I try to burn it or explode it. Physical changes, some examples are melting, breaking, slicing. Basically, anything you can do to a substance without changing what the substance is. A good question to ask yourself here is, can I take it back? If I can take it back, then it's not a permanent change. So I can melt ice, but then I can take that water and freeze it back into an ice cube again. A chemical change is going to be more permanent. I can't reverse the chemical change without another chemical change. So I'm going to look for some bubbles, or maybe odor, or a change in energy or color, or I'm going to look for a precipitate. Now, just because something bubbles does not mean that it's a chemical change. So when I open my Coca-Cola, I'm going to get bubbles. There's no chemical change there. That is a phase change for the gas bubbling out of the liquid solution into the air. So the bubbles I'm looking for here are more bubbles that I can't explain any other way. Same thing with odor. If I don't smell anything and then I add two chemicals to each other and then I do smell an odor, then that odor is an indicator that there was a chemical change when those two chemicals combined. Change in color and change in energy. If I react two substances to each other and those two substances become very warm to the touch as they react, then I know that I've had a chemical change take place. A precipitate is anything that settles out of solution. So when we talk about precipitation, it's not always rainfall. And the reason we call it precipitation is because it settles out of our atmosphere. So snow, hail, sleet, rain, all of those are precipitation. And so when we put two liquids together and a solid settles out of solution, we call that settlement a precipitate. Now, when chemicals change and create new chemicals, we have what is called a chemical reaction. And those chemical reactions follow the law of conservation of matter and energy. So what it states is that matter is neither created nor destroyed. What that means in English is that what I start with, I need to end with. So I must have the same total mass after a reaction as before. I'm also going to use this later when we balance chemical equations because I need to have the same number of atoms as a reactor as I do on my products. So look at this example. We're told that we have magnesium chloride reacting with sodium that produces sodium chloride and magnesium. And I'm told that I'm given 50 grams of the magnesium chloride. And it produces 40 grams of sodium chloride and 22 grams of magnesium. And this information about sodium is left blank. Well, what I have to do is decide how much I need there. Well, based on the law of conservation of matter, my beginning has to match my end. So 40 plus 22 is 62. In order to get 62 over here, I need 12 grams of sodium. Balancing comes from the law of conservation of matter as well. I have this equation, sodium plus chlorine yields sodium chloride. Now, the 2's that are in green are not written to start with. Sodium by itself is 1 atom, chlorine by itself is 2, and when sodium and chlorine combine, I have 1 of each. Now, I need to have the same number on the left as I do on the right. And when I say the same number, I'm talking about the number of atoms. So when I look at Na with 1 here and 1 there, that's okay. But when I compare my chlorines to each other, I had 2 to start with, and I ended up with 1. I have to have the same number as I start with when I am finished. Reactants yield products. This arrow means yields. Here are my reactants. They yield this product. Now, there's only one way to balance a chemical equation, and it's using coefficients. Those coefficients may only go in the front. And if I leave a space in front blank, that means I have a 1, not a 0. I cannot change subscripts. So I can't just come over here and add a 2 to this Cl, because Na and Cl are 1-to-1 combination. It takes 1 sodium to make 1 chlorine happy. So what do? I look at my beginning and my end, and I ask myself, what is our balance? Well, I need 2 chlorines here at the end. So I put a 2 in the front because 2 times 1 is 2. That matches this, 1 times 2. So I'm good there. But as soon as I put this 2 here, that throws my sodium off. Now I have 2. So I need another 2 over here to make my beginning match the end. Now I want to talk to you about the different types of reactions. The first 2, synthesis and decomposition, are exact opposites of each other. So I want to talk to you about them in comparison. A synthesis reaction is when we take 2 or more smaller substances and join them together to create 1 new substance. Decomposition is when I take 1 substance and split it into 2 or more separate substances. Now, because this is a 2 becomes 1 and this is a 1 becomes 2, I like to call these marriage and divorce. Marriage is when 2 people join together to become 1 unit. And divorce is when that unit isn't working anymore. They will split into 2 separate individuals or homes. So if you look here at this example, I have hydrogen combining with oxygen to form water. That's 2 separate things. I know they're separate because there's a plus sign here, joining together to become 1. So this is an example of synthesis. Now, down here, I have one thing, calcium chloride, is breaking apart into calcium plus chlorine. I know these are separate because of the plus sign. So that's 1 splitting into 2. This would be a decomposition reaction. Notice that these equations are balanced, and I do not need coefficients here because this is a naturally balanced equation. I use my coefficients here to balance that synthesis reaction. The next 2 types of reactions we're going to talk about are single replacement and double replacement. Kids often get these confused, so I wanted them side by side for you to see the similarities and differences. A single replacement is when we create a new substance with 1 substitution. A double replacement is when we create 2 new substances with 2 substitutions. I hope that you see the 1 is with single and the 2 is with double. Now we need to talk about what those substitutions look like. Here's sodium and chlorine and hydrogen. Now sodium and chloride are bonded together and hydrogen is alone. But at the end of the reaction, hydrogen has kicked out or substituted itself in the place of where sodium was. So now chlorine is bonded with hydrogen and sodium is alone. I call this divorce with an attitude. Here's the happily married couple. Hydrogen moves in, kicks sodium out. So now there's a new substance because of one substitution. Now, this double replacement works a little differently. Hydrogen and chlorine are together. Sodium and hydroxide are together. At the end of the reaction, hydrogen is with hydroxide in the form of HOH here, and sodium is with chlorine. So now everyone has a different partner. Sodium and hydrogen have switched places, and there's two substitutions because sodium takes the place of where hydrogen was, and hydrogen takes the place of where sodium was to create not one, but two new compounds. Notice that these equations are balanced. This one required coefficients in order to balance it, and this one, even though I see a subscript here, is already balanced because there are two hydrogens here and two hydrogens here, one oxygen, one sodium, and one chlorine.